Hello, so my science experiment is on how different types of water affect the clarity of ice. And so the hypothesis that I was testing was, what is the effect of the clarity of the ice cubes when using different types of water? So we chose to use tap water. I chose to use tap water that had been boiled once, and then I also used tap water that had been boiled twice. And so I froze all three types of water into ice cube trays, and then at that point we tested the clarity of the ice cubes once they were frozen. So something that I predicted the outcome was going to be was that the more you boil the water, the clearer the ice cube will be. And so you'll see that the results will go to show and go to prove this outcome statement. So some key vocabulary that you need to know in order to do this experiment. You need to know the definition of clarity, and that's the quality of transparency or purity, the ability to see through something. And so when we're testing the clarity of ice, we're going to use light to see how much light comes through the ice cube, if there's a lot of light that comes through or just a little bit of light that comes through due to the clarity of the ice cube. And then another thing to know is lumens. So lumens is the way we measure light. Because you cannot say that there's a certain quantity of light, the quantity of light in which light is measured in is called lumens. And so it is a unit of light quantity, and so that is how we did our measurements for this experiment. So the manipulated variable was, again, like I said, the types of water. So we had one tray of non-boiled tap water that we put into this tray. And then we also had boiled tap water. This tap water was only boiled one time, and then we let it cool. And then the last tray that we had was the boiled tap water that I boiled twice. So these were the three manipulated variables that changed. As you can see, the ice cube trays are the exact same size, exact same brand, nothing changed about these. And then the freezer we put them into was also consistent. So that's what we call our constants. And then the water also came from the same source, which was our kitchen sink. So the responding variable that we were looking for out of all three of these manipulated variables was the clarity of the ice. So again, you needed the ice cube trays, you need pots to boil your water in, you need a freezer in order to freeze that water, and then you also need a flashlight that has a few different lumen levels, and all that means is a few different brightness levels, and in common terms is just brightness levels. So on the iPhone 13, for example, there are 4 levels on the flashlight, and so that is what we chose to use to test the ice cubes. And so we started each ice cube at the bottom level and worked our way up until we got to see the light come through the ice cube. And then we also used a tripod. That was for the sole purpose of making it easier for us. We just mounted our cell phone to the tripod. I turned the flashlight on, and I was able to use the tripod as a hands-free device while I was messing with the ice. So the first thing that I did was I filled the ice tray of the non-boiled water, so just regular tap water went into the first tray. And then I started the boiling process. So I boiled a pot of water one time, set it to the side, let it cool. And then I boiled a second pot of water and boiled that, let it cool, and then I boiled that pot again for a second time and let it cool. So at that point, once both pots of water pots of water were cooled off. At that point, we were able to pour the water into the ice trays. And so I labeled, as you can see, I labeled each tray. That way I knew which tray it was. And so we filled the ice trays with the water, sealed them shut, put them in the same spot in the freezer, and let them sit for 24 hours to freeze. So after the water froze for 24 hours, we took the ice trays out, and I actually only took one ice tray out at a time so that the other two could stay frozen while I was testing one tray of ice cubes. So I placed each ice cube up to a flashlight to measure the clarity of each ice cube. I don't know if you can see it here, but this ice cube is sitting on top of the cell phone flashlight. And you can see in the center here, you can see some light starting to come through, but it's very interesting because the ice cube in its entirety is very opaque, very not clear at all. So this was one of our tap water ice cubes that we tested. I also had to wear sunglasses because the amount of light that my eyes were digesting was a little bit too much. So sunglasses are recommended if you're going to do this project. So the data did not necessarily surprise me. It was pretty consistent with what I predicted. So we entered our data in measurement of lumens. So for each level of lumens on the iPhone, we had those measurements here. So an iPhone 13 can go all the way up to 50 lumens. So we divided that into 4 for the 4 levels of brightness that the iPhone had. So the smallest amount of lumens that the iPhone puts out is 12.5 lumens. The second level is 25 lumens. The third level is 37.5 lumens, and then the highest level, which is the highest brightness, is 50 lumens. And so you'll see throughout our data chart, it shows some consistency with each type of ice cube in the lumens that it required for us to see the light shine through the ice cube. So, for example, the tap water required the most lumens, the highest brightness of light, in order for us to see the light. And so if we put it at the lowest brightness setting, you could not see the light very well, and so we had to kick it all the way up to the highest lumens level in order for that light to peek through, which just means that the clarity was not good. There was not a lot of clarity in those ice cubes at all. But as we worked through the boiled water and the twice boiled water, it seemed as if boiling the water created more clarity in the ice cubes, and so we were able to see the light much quicker at such a lower level. And so that's why you'll see the twice boiled tap water really only required 12.5 lumens for that light to shine through the entire ice cube. There was the occasional ice cube that was a little bit more on the opaque side, but on average, you can see that the lumens that it required to see that amount of clarity was much less than the tap water. So again, as you can see with our data, you can see the tap water had the most required lumens in order to see the light shine through the ice cube, whereas as you work through the boiled water and then the twice boiled water, less lumens were required, and therefore our data lessened in quantity as well. So this is a great and unique graph that shows the data pretty clearly. Each color line represents the different type of water that we tested, And so you can see in that higher range of the graph, the tap water, again reflecting the higher amount of lumens that were required for that light to shine through. And then again, you have your once boiled tap water and your twice boiled tap water, which again are consistent, and it showed lower required lumens for that light to shine through. So the results and the conclusion were very consistent with what we predicted. And so it was very interesting to see how, as you boil water more and you let it cool and you freeze it, more impurities come out of the water and allow the ice cube to be a lot clearer. So there's things such as bacteria, various impurities that can be in our water. And this is not just tap water, it can be any water. But as you boil those impurities out, just as if we boil water to drink it safely when we don't have clean water available, boiling water, we know, takes the impurities and the bacteria and the viruses out of that water. So as we do that and we put it in the freezer to freeze, the ice cubes become clearer and more transparent, and the clarity of those ice cubes goes up. So again, some real world applications. The ice, if it's going into a drink, if you want a crystal clear ice cube, you know that you're going to need to boil it in order for that ice cube to be crystal clear. The sculptures that use crystal clear ice are used with top of the line, very, very, very clean and purified water to allow for that ice to be as clear as it is. And a safety aspect of this is that if you don't want the bacteria or the viruses that are hiding in the ice cubes, those ice cubes melt, and those ice cubes end up infecting whatever drink you have them in. And so as a safety point, it's important that we make sure that we are boiling our water. If you want your water super pure, then you boil it and you freeze those ice cubes, and then your drink will be as pure as possible without those bacteria or viruses or impurities melting into your drink, which you end up digesting as you drink that beverage. So this project was fairly, it was a pretty short project. You can do it within a matter of 48 hours, but I did stretch it out a little bit. But as long as you give yourself 24 hours to let the ice cubes completely freeze, that will give you the best results, because all of the ice cubes have to be absolutely frozen in order for you to test this theory. Okay, that's it. Thank you.